Okay, welcome back. So, in the previous video, we were looked at how to estimate the quantity of e-waste that is being produced. So, one another aspect which is very important in terms of the e-waste management is many times when you look at some of these newspaper clippings and other places, people say that there is a lot of money that can be made out of e-waste, and this because of all this presence of this precious heavy metals and other stuff. So, we will try to quantify some of those numbers right now. So, how much actually money is there, assuming that 100% of this precious metal which is present on in this electronics is available for recovery, and for that of course we need to have different recovery technology, which we'll talk about that maybe in third or most likely in third week. So let's look at, so what I'm calling it is an economic assessment. Say, of course, we talked about that e-waste is a problem, we talked about the human health issues, and we'll talk a little bit more in terms of human health issues later on. And we talked about how to estimate how much e-waste is produced. Now I want to bring you to show you some data, some calculation, where to see that if we collect all this e-waste which is being produced in a particular city and try to recover all these precious metal, how much money can theoretically be made. It is, again, I am saying theoretically, be careful with that, because that's assuming that 100% of those metal can be recovered, which may not happen in most of the cases. Actually will not happen in most of the cases. So, we will do what is known as the economic assessment of e-waste in this particular module. That's the focus, that's my goal, to get to have this economic assessment. So, when we try about economic assessment, it's essentially to find out how much precious and special metals are there, and they are being lost because of the inefficient recycling process. That's what we keep on saying, that we need to have a better recycling process. Informal sector is not able to manage this e-waste recycling because they don't have the requisite technology to do that. So, we have to provide requisite technology. That's, we need to have a nice merger of informal and formal sector, where the informal sector does the collection and maybe initial part of the recycling process, dismantling and other stuff, and this is specialized recovery of precious and special metals, where actually where there is a good amount of money, and that should be left into a more specialized, because otherwise using all those acids and burning and all that, we are contaminating the environment. E-waste is considered as a resource and requires use of an efficient, and it can be done in a sustainable way. There is a recovery of these materials does provide significant economic opportunity, and it can create lots of jobs, produce new type of industry out there. Of course, that's one area where the country right now is struggling. We are having our GDP numbers for most part is going up, and from time to time there will always be some hiccups because of something or the other. So, but in general, economically we are making progress, but many times you see in the newspapers and other places that this progress is jobless. It's a jobless growth. So, we need to have industries out there which can create new jobs, and this electronic waste is a problem, but it also provides an opportunity to create more job in this particular sector, because money can be made, and then money making is not a bad thing. Actually, for business, money making is a must. Unless the business makes money, how they will invest to produce more jobs and produce more companies needs to be set up in the country to give jobs to all that young people who are graduating from different colleges and universities. So, and that's one aspect. The other aspect is it also helps into reducing the environmental impact due to mining of virgin material. So, we have these materials in electronic waste, precious metals, special metals, we call them rare earth metals. The reason we call them rare earth, because they are rare, they are in very minute quantity available in the mother nature. So, and then mining them is a very tedious process. When you do the mining of these these rare earth metals, you are actually ending up contaminating the environment also a lot. You use a lot of energy, use a lot of water, and this mine tailing management, overburden. So, these are also leads to environmental problems. So, if we can do this recovery of this precious metal from this e-waste, we can reduce the impact, we can reduce the environmental impact due to mining of virgin materials, which is also very, very significant impact that is happening from the mining sector. So, let's try to see it. So, it's there are electronic waste, there is a variety. Let's see where we were. So, yeah, we were in terms of it's a variety, there are different types of electronic waste out there based on this age, origin and manufacture. Amount of different types of precious metal present also varies from one electronic to another electronic. So, it's not the same. And then it has a various metals are there. You will see lots of copper, aluminum, steel, and there are lots of gold and other stuff too. And we'll talk about these previous metals in a minute. A wide application in the we already talked. You saw some of these when we were talking about the health impact, and why they are used, because they act as a contact material because of high chemical stability. They are good conducting properties. So that's the reason these heavy metals are used. So let's look at this periodic table. If you remember the periodic table from your school time, and or maybe from first year of engineering and other places. So that's the periodic table. So from the periodic table, I have just taken 6 metals. So this is not only the 6 metals which is there in electronics, but let's look at these 6 metals. So we have copper, silver, gold, platinum, palladium and rhodium. The ones which is taken which has good economic value, which is so copper approximately, and these numbers are this is approximate number. Don't if the numbers are a little bit off, that's okay, because we are just trying to do some math here for calculation. So because this prices also keeps on fluctuating, but this is an approximate number. The copper is around 400 rupees per kg, silver is 40 rupees per gram, and so it will be multiplied by 1000 to get how much it will be for kg. Gold is around 3000 rupees per gram, which is 30,000 for 10 grams, which is although on the day of demonetization it was sold sometimes 60 to 65,000 of for 10 grams, but regular price is around 3,000 rupees per gram. Platinum is around 2,900 per gram, palladium is 1,800 per gram, rhodium is 2,500 per gram. So this is platinum and rhodium is very much similar to gold. Sometimes actually they are more expensive than gold. Palladium is also it's pretty like expensive metal. Copper, we know copper is recycled, good value. Silver, good value. So based on all these numbers, there is a importance of these heavy metals. If we can recover these heavy metals, if we can recover it from these electronics, they are used in electronics. Copper may be in more quantity. There's silver, gold, platinum, palladium, rhodium, not in a great quantity, as you will see. So if you just look at one cell phone, the numbers is not that significant, as you will see when you do the calculation. But when you look at the entire amount, because lots and lots of e-waste is coming in. So in terms of since the volume is so much, it's we can recover a substantial amount of money if you think about the economic assessment from these electronics. So this is like just these base prices for some of these stuff, and then we have metal recovery concern, because things are there in the periodic table, and they are, rather than mining it again and again, it's better to recover from the waste stream and try to reuse it, because that's why we reduce the impact from mining and all that, which we talked about. And this is where these are some of the components where they are used. This is what are the possible chemical elements that are used, and based on coming from different papers that has been done over there, we can provide you this references detail on through the online portal, through the discussion forum. We can put we will put like a PDF with all these papers with their references. If you are more interested in that, just let us know. But as you can see, in terms of the major chemicals present, these are lots of chemicals, and although we are just focusing on 6, but there are several more out there which is used in electronics in different components. So a lot of heavy metals that can be recovered, and it all depends on economy of scale. Then another example of the same thing, you have the doping material, silicon control, fluorescent lamp, wiring and all that. So then these are the possible heavy metals present there. Let's see, this is your possible chemical elements present there. These are the references from which we got that. So we did some homework in terms of getting all this information together for this course. So then we looked at this already, and so if you look at the material composition of the different electronic items, again the numbers are a bit small for you to see on this particular screen. That's why the PDF will be provided to you. But here, what is the thing is that these are the different from the different sources. One is the LCD notebook, 2 is LED notebook, 3 is the CRT, 4 is LCD TV, 5 is LED TV, 6 is CRT monitors, 7 is LCD monitors, 8 is LED monitors, 9 is cell phone, 10 is a smartphone, and 11 is photovoltaic panels, 12 is hard disk drive, 13 is SSD drives, and 14 is the tablet computers. And here are the materials. So, all the different materials that are used, and like how much gram of these is present per unit of these materials. So, as you can see, some materials are used quite more. For example, antimony pretty high, aluminum in this ranges is 242, 130, 130. Then glass, sometimes you see pretty high glass amount being used, especially for when number 3, which is the CRT TVs, or number 6, which is the CRT monitors, lot of glass. Number 11 again is a photovoltaic panel, lot of glass is there. So, based on different types of stuff, lead, lot of lead, you see pretty high lead also showing up, lead quantity is showing up pretty high. So, that's mercury is being used as well. So, in some items it is being used, some items it is not being used, but this is a material composition of different electronic item. This particular study, they have summarized it and put it in this nice table for us to use. So, why this is important? We will take this data, we will take this data and the price data, and then we will try to come up with, and this is your material again, this is for another material, molybdenum, nickel, palladium, plastics, platinum, steel, iron, and you can see all these how much gram per unit in different types of electronic items, and this is from this particular source. So, again this table and the previous table shows us in terms of the different elements present in what is their gram per unit. Then we need to know what is the average value of those embedded material. This is again from that particular paper itself, where they have put euro per kg, and this is done in European Union. So, that is the average value, and the mu is the standard deviation. So, if this is the average, and that is the standard deviation for aluminum, antimony, arsenic, beryllium, for all these different elements which is there in electronic waste, what is their typical price? And see, these prices do fluctuate a little bit. So, you can always take plus minus 10, 15, 20%, but like just for the calculation sake, just to get a rough idea of how much money is there in that particular range, we can use this number. So, we have taken this average value. We have taken this average value for all these materials which is out there, and we took the data from these two tables, this table and the next table. We take the data from there, we took the average value of the embedded material from there, and then we came up with material value of a typical smartphone. I am sorry, this slide does not show up very clearly. We will change the color before putting in the PDF of that, but here the number, essentially this is the first here the concentration is given in gram per unit. This is the price is in euro per kg. Total, then we calculated total value in euro. So, we multiply this by this, taking into consideration particular unit, and then we from euro we took it to Indian rupees, and then this is the total value we get, which is 175. Average value is like a 175 rupees. So, we are getting a value of 175 rupees per average smartphone. So, in one smartphone, from the heavy metal itself, from the heavy metals present, there are other things present there too. You can think 175 rupees, what is the big deal in that? It's such a small number. But again, you have to be taken that we are taken all the models, all the makes, old phones, new phones, some of the mostly older phones, newer phones actually may be a little bit more pricey, more fancy things over there, but that's 175 in one phone. And if you think about all those numbers that we estimated in the previous video, and with the increase in usage of cell phone in India over the coming years, as you can see in this graph from 2015 to 2022, these are the projected numbers, and as you can see, more and more cell phones will be used. That means more and more will be discarded, taking a lifespan of 3 years. Average lifespan of a smartphone is 3 years. And 80% of them are assumed to be disposed. So, 20% will be stored, but 80% will be disposed. So, if we take 3 years as the average lifespan, 80% of as the obsolete item being disposed, if you can do the mobile phone, how much money is out there just from the mobile phone in India, in 2020 we are looking at a figure of 450 crores. So 450 crores of worth of these heavy metals are present in, just because we are looking at, see here, million numbers are pretty high. So although it's 175 for one phone, when you add up to all the phones that is going to be disposed into the environment, we are looking at a 450 crores. To set up a very good fancy waste to like a electronic recycling plant, say it cost around 50 crores, just an average, it may be a little bit more than that, say even if it's 50 crores. So what you are looking at, 9 good waste to energy, 9 good e-waste recycling plant. If my number is off, just let me know, because I'm not a I've not set up a e-waste plant, and if we can, I'm just making an estimate here. 50 crores is a pretty good number, I think, for a good e-waste recycling plant. So if we can set up with the expense of say 50 crores for an e-waste plant, e-waste recycling plant, we can set up 9 plants in the country just from the e-waste that is being, just from the mobile that is being going to be disposed in 2020, 80% of that. So 80% of the mobile coming in, which will be thrown away, which will be people will not stop using it, which will become electronic waste in 2020. If all of them is captured and brought it to a nice e-waste recycling facility where we can recover these material out, it will have a value of around 450 crores, and that's based on today's number. If the metal prices goes up, the number may be a little higher, and the number can go down as well if the prices go down, because market do fluctuate, but most of the time it has a tendency to go up only, at least with inflation and all. So that's a lot of number. So that's what and that's why there is an interest in electronic waste. Of course, the electronic waste interest is there because of the human health impact, the environmental impact, and the problems associated with that. But at the same time, the interest is also there because there is a lot of money. There is a lot of money can potentially be made, which can be used for making a good industry out of that. So it does present a good chance of having a very good study in industry in terms of electronics, in terms of e-waste to recycling industry in the country. So this is another case study too we looked at, that was for mobile phone. Now if you look at the LCD notebook, LCD TVs and LCD monitor, if you get all these gram per unit, same thing, same way for these, and then you try to do in terms of how much LCD television, LCD notebook and LCD desktop monitor in different years, how much will be obsolete, and then embedded metal cost. So here we are looking at for the different years, say in terms of LCD desktop monitor, which is at the bottom, here we are seeing a value of 290 crores in 2020, and for this is 83 crores from LCD television, 83 to 107 crores over those 4 years. For LCD notebook, 37 to 104 crores. LCD desktop computer, 104 to 290 crores. So more and more LCD desktop computers will be actually, desktop monitors will start showing up into the disposal stream. So again, this again reinforces the same thing which I was telling just a few minutes back, that there is a value in this e-waste. And e-waste, as when we talk about municipal solid waste, or when you hear the term waste to wealth for a mixed municipal solid waste, the way we manage it in India it's still a long battle, because I don't think with the mixed municipal solid waste that we have available in the country as of now, and those of you who may have taken my course in the previous semester where we had this integrated waste management course, we talked about that in great detail, that it's difficult to make money out of that because of the heterogeneity of the material. So materials are all mixed together. They don't, the process doesn't work efficiently because the input to that process, inputs to the technology is not proper. We have things mixed up. If we do the source separation, yes, we can potentially make some good money out of there, potentially, and that too requires a lot of investment and other things to happen. Electronic waste is much easier because it's very easy to separate e-waste from other waste streams. They look different. It's easy to recycle, easy to ask people to keep it source separated, because you don't dispose electronics every day like you do for municipal solid waste. In e-waste you do it like once in maybe once or twice in a year for certain items. So, you can always have collect it separately. So, if you collect it separately and recycle it and try to recover these heavy metals, there is a lot of money can be made, and that can lead to a actually very nice sophisticated engineering and technology job in the country. Hiring everyone from like a diploma holder to ITI to a graduate engineer. So, it's and even management people. So, it's a good market potential. So, e-waste I hope there are some companies coming up, they are struggling to get the e-waste. Hopefully, with this new e-waste management rules, they will be able to get some electronic waste to recycle, and they can do this metal recovery. Many of these precious metal recovery, many of the plants that we have right now, they are unable to do this precious metal recovery, and we do end up sending them for Belgium and other places in Europe. But if we can do it over here, we can generate a good revenue from there as well. So, the same numbers now presented in terms of graphical representation. As you can see, the desktop monitor is kind of leading. It will the embedded metal cost in crores. So, it's 220 crores, which is we expect from there. LCD notebook is the next, then LCD television is kind of in the middle compared to LCD television and notebook for 2019. 2020 seems to be very similar, but other years we see that television will be higher than the notebook, and then monitor will be much higher. So, that is kind of gives you the economic assessment of electronic waste. We talked about the economics, and so far what we have done in this this is kind of, I think this is the last, yes, this is the last video for the week 1. So, if we can think about week 1, what we have done in the week 1, just a quick recap. So, we started with looking at what is electronic waste. We classified it. I did emphasize that based on where you are in the world, with whichever literature you are looking at, the classification will be a little bit different. So, you need to be careful with that when you look at any report. There are different ways of classification. Some places this big ticket items like refrigerators, washing machine, dishwashers, they are not included in e-waste. In other countries they do. European Union they do it. So, in India also we do that, we do include them in the electronic waste. But if you are in US, they don't. They call it white goods and it is handled separately. In general, very general definition of e-waste is anything with a circuit board is an electronic waste. So, even those, while if you are in a railway station or in an airport where you see a small kid walking with their lights flashing in their shoes, or making some that sound like small musical things in those shoes, that also can that also is an electronic item as per the definition of electronic waste. And then once that shoes is discarded, it's an electronic waste as well. So, as per the European Union definition, but it's not an electronic waste if you are in US. So, US don't call it a, but we follow European Union in India. So, for us also that will become an electronic waste. So, that's in terms of how you need to be careful in terms of the definition. Then we talked about what are the concern. We looked at what are the different types of heavy metals present, and what is the why we should be concerned, where in India it is being produced, how much it is being produced in India, which cities are producing more, which states are producing more. Then we went into looking at that health impact, like briefly in the health impact, which we'll do a little bit more detail in the first video in the second week. And then we talked about how to estimate, like if you have to do the forecasting of electronics, how to estimate and we had a case study of Delhi where I showed you how to do the estimation of e-waste generation. Followed by our focus was on in terms of the estimate of e-waste generation, if we know the quantity of e-waste from the different waste stream, and if we want to see what is the market potential of setting up a e-waste recycling company, how much money theoretically could be made from all those precious metals and other things which is out there. So, we kind of did those calculation using the data available in the literature. Again, we have used lots of information from different literature sources. We will try to put some of those important ones on the website, so that on our NPTEL website for this course as the additional reading material along with these lecture slides. But if you need some more information, if you get more, feel free to contact us through the discussion forum. We will be more than happy to answer any question. So, that brings a closure to the week 1 video. So now we'll go into the week 2 in the subsequent video. Again, there will be an assignment as happens to any LPTL course. So go through the assignment questions, and you will have I think it's around a week or 10 days, which directions have been provided to you anyway. So you can look at when the assignment is due, pay attention to that. And again, assignment questions, if you have any confusion, put it on the discussion forum. Discussion forum will definitely get answered within 24 hours. So anything you put it on discussion forum, I promise you that we'll get back to you in 24 hours in most of the cases, unless there is something happening but in general, we'll get back to you within 24 hours. So with that, thank you for enrolling to this course. Week 1 is over, so 25% is done, another 75% left because it's only a 4-week course. You have done week 1, and you will get done other weeks as well. And I hope you continue enjoying this course. Thank you.